My name is Peter. I work on the Firebase team, so if you have any questions about Firebase, feel free to find me later on. I am more than happy to answer, and if I can't answer myself, I am happy to find the people who can answer. This talk is about how I built a second brain using Firebase, Gemini, Genkit, and Siri. And if you've been at any of the other conferences in the past couple of 2 years, you might have seen a variation of that talk. So the very first version of the talk was called How I Built a Second Brain Using Swift, Firebase, SwiftUI, OpenAI. At one point there was LangChain in there. But over time, I found that as Google was implementing more and more of that stuff ourselves, I was able to swap out all the parts, and now it's mostly Google technology that is under the hood, except for iOS and Siri, obviously. So I often say I'm a developer advocate, but we've changed the role title a while ago, so I'm officially a developer relations engineer. If you want to follow me, you can just use first name, last name at pretty much all of the social networks. I've noticed that a lot of people started following me on Blue Sky, even though I'm not posting there actively, but maybe that will change. All right, so making Siri smarter, is this even possible? Right? So I don't know about you, but it seems like Siri is not particularly helpful for a lot of things, and that part of the joke, it probably hurts because most of us here use Siri for setting an alarm or a timer and stuff like that, but you really want to use it for more than that. And today we're going to look into how to make that possible, and I'm super excited for one of the talks that is later today, where Stefan shows us how to build a version of Siri or Apple Intelligence that you can run on your device, even though you are in the EU, which currently is not possible, except for if you jump through a few little hoops. So what is the problem we want to solve? Information overload. So you might be in the situation where there are just too many good articles out there. And these screenshots are a couple of months old, but there are just so many really amazing content creators out there who create content on a regular basis. If you just, we heard from Antoine that he's creating a new blog post every single week, so that is one article that you need to read every week, and then there is a bunch of other people as well. So, even if you just want to follow the iOS community and the Swift community, that is a lot of stuff that you need to find time for. And there's probably an app for that, right? So let's take a look. We've got apps like these, right? So, and I'm sure that probably a lot of you have one or maybe several of those apps on your device. At one point, I had all of them on my device. But there is a problem. Everybody awake? Right. So they were not invented here. Well, that's not a real problem. So I'm always on the lookout for stuff how I can explain Firebase technology with something that is slightly more exciting than, hey, here's how you use Firestore, with some contrived example. So I thought, why not build a read it later app? And also, I run a newsletter, and I need to curate all those articles. So, I need to collect the good articles and then take notes about what I want to write about it. And so that's a lot of stuff to go through. If you look at that, it's a bunch of articles. And I take the time to read the articles and write something that I think about them. So it's a lot of work. The good thing is that the newsletter engine I'm using has a really nice API. And instead of using this form where you can input the stuff yourself, you can call this endpoint here, right? So I was thinking, okay, so I could write an application that, one, allows me to read articles later and collect them, and then the ones that I really like, I want to send to this API. So that's what I did. So build a read it later app. And here is the application. Let's see if there is an animation. Maybe there is. Well, so you can add links via the iOS share sheet. I use Open Graph to extract information from the article. So if you write blogs yourself, make sure that you fill in all the good details like the title, the description, the author, provide an OG image, so that instead of showing just this red thing, I can show a nice image of your hero image. And in addition to doing that, what this application also does, it simplifies the formatting, because it turns out a lot of articles or a lot of stuff that you find out there is formatted in a way that looks very interesting, but makes it slightly more difficult to read it. And then there is a lot of ads in between, right? So you probably don't want to have these. So you want to filter these out. And another thing that we wanted to achieve was offline reading. So this application supports offline reading by way of using Firestore. Okay, so, but there is still a challenge. I still need to read all those articles. So how can we get around that? So the solution is building an AI summarizer. And there are a lot of ways to do that. And one way to do it is to use an AI. And here I use ai.google.dev, which allows you to talk to the Gemini model. So here on the screenshot, we can see in the introduction that it says something like, please summarize the following text for me, provide a synopsis in less than 5 sentences, and a list of up to 4 tags for categorizing the blog post. And instead of just showing you the screenshot, I'm going to show you a live demo. So let's see how this works. Okay. Here we go. So here is my, and it's probably too small for you to read. Okay, so here is my system instruction. I pasted this entire article in here. So this is basically a copy of an article that I wrote on my own blog about task modifier. And then I can configure all sorts of parameters, how I want to use the model. For example, I could pick a different model. I'm using Gemini 1.5 Flash, set the temperature, and so on and so forth. And then, so I think because I ran this before, I need to delete the answer, paste it here. Okay, run this. Okay, and then here's the answer. So this blog post explores how to implement a delay feature in SwiftUI using the .task view modifier. The author demonstrates how to leverage the task.sleep4 function to create a custom view modifier, and so on and so forth. And then at the bottom, you see the tags. It extracted SwiftUI, async programming, concurrency, and view modifiers. And I think it did a pretty good job. So the next thing that you could do is, well, instead of going into a development tool like ai.google.dev, you might want to build something like that you can use in Gemini. And Google recently released a tool called Gems. And it's similar to a custom GPT, right? So I can take my prompt here, and then go into this tool and create a new gem. I'll call it demo. I put my prompt in here, press the magic wand button, and then it will give me a much better prompt. It gives it a purpose and goals. It sets the rules for engagement, how it should behave. It talks about the tagging, about the overall tone. And now let's take one of Antoine's articles. Oh, wait. Let's just copy everything. Let's see how it works. So I can put it here. Okay, this article provides a comprehensive guide to using the main actor attribute in Swift for ensuring UI updates are performed on the main thread. It explains the concept of global actors and so on and so forth. The tags are Swift, concurrency, main actor, and iOS. So I can now iterate on this thing and optimize it a little bit more, and then save it, and then let's save it actually. Well, I did save it, didn't I? It can't save. Yeah, I don't know. Anyways, so yeah, close without saving. Okay, so let's take a look at a different one, right? So, for example, I've got a Swift style guide expert. So I put all sorts of style guides in there. So now, if I have a question like, should I be naming my my Boolean properties is blah, blah, blah sheet presenting or presenting blah, blah, blah sheet, I can go here, ask the question, and get an answer. And it will say, well, you know, you want to do this or do the other thing. So that is pretty cool. Let's get back into the presentation, though. So you saw two tools. And the first tool I showed you has another feature that we can now use. It allows you to copy code that you can use to talk to or to make use of the SDK, right? And here's the code that you use to talk to Gemini using the Google AI SDK. And we can copy that, paste it into our application, and then just use it. Here's the SDK. We've got SDKs for Python, Node, Go, Kotlin, Dart, and Swift. But here's the thing. This SDK requires you to put an API key in your application. And you probably know that if you put an API key in your application, it is relatively trivial to exfiltrate this API key, right? So anybody could download the application, which is what they do when they install your application on their device. Then they can open the application in a hex editor and then just go through and look for something that looks familiar, and then boom, they have your API key, and then they can use your API key to talk to the backend and cause you a huge bill. So not great. And this is why we recommend using the Google AI SDK only for prototyping and not for production, at least for mobile applications. It's a different story for if you have a backend application. So Firebase is here to save the day. We thought, well, how can we make this better for people? So we built the Vertex AI and Firebase SDK, and I apologize for the name, which is a way how to use Gemini in a secure manner in your mobile application. It has the same API, it's just a different way to accessing the model. So any code that you've written before and the code that I've copied before, you can just continue using it, and all you need to do is change the import and set up a Firebase project that you connect your application to. I think a lot of people here probably already use Firebase, so that's not an extra step. The advantage of using that is that it's enterprise ready, no API key required, and it supports app check. So app check is Firebase's solution for protecting the communication between your application and your backend. And that is probably something that you should be using anyways to make sure that any request coming into your backend, you can be absolutely sure about that is from your legitimate application and not from somebody else who managed to somehow steal an API key or find out where your backend is located. So definitely recommend doing that. So how does the code look like for summarizing something? Here we have a function that is in my knowledge base application, and I just pass in the text of the article I want to summarize. And here we call the Vertex AI SDK. We call generate generative model to set up an instance of the model. Once we've got that, we call it generate content with the prompt, and the prompt really just is, please summarize the following text for me. When I showed you the gem and the magic wand button that helped me improve my prompt, that is definitely something that you want to do. I just didn't do it here because the prompt would be very long and it would be difficult to fit it on a slide. And then you get the text back, and you can return it and display it to the user. So that is how you implement a summarization feature for your application. And here is a demo. So here I have an article. I go in, I tap the magic wand button. It makes the call to the Vertex AI SDK, goes to the model, and here I get my pretty lengthy summary. So that is using the simple prompt, which just says, please summarize this for me. And as you saw in the demo, in the other demos, when you use a more elaborate prompt, the summary actually is more concise. Cool. So in conclusion for that part, use AI Studio to prototype your prompts. Use the Google AI SDK to call LLMs directly from your client. But then for production, or once you go into series mode, use the Vertex AI and Firebase SDK to make your calls. Do secure your communication from your client to your backend using AppTech. And then, of course, now there is the question, should you always call an LLM directly from the client? I think there are some really good use cases for actually doing that. This one is one of them because you already have all the data on your client, but oftentimes you have a lot more data that you can't possibly pull down on the client, and you want the model to operate on that data. And for solving for that, we need to choose a different solution. Introducing QA with my second brain, right? So I put all those amazing articles from the community into my knowledge base, and now I want to have a conversation across all of that, right? I want to have a conversation about how does Swift concurrency work, and I want it to take into consideration all the good articles that Donnie wrote, and that Antoine wrote, and that Matt Messicott wrote, and all of the other articles, right? And maybe even the documentation. But I want to be very specific. I just want the model to operate on the articles I selected and not the general world knowledge. So I need to tell the model, please use just my data. So how can you do that? And to explain how you do that, we need to take a step back and talk about vector embeddings. So who here has heard about vector embeddings? Raise your hand. All right, cool. So everybody's going to learn something. So to understand what vector embeddings are, let's assume the following task. Find all the words in the following text that are food. I went down to Aberystwyth on foot to buy some Welsh cakes and a few berries. When I finished doing my groceries, I had a latte at coffee number 1, where I met a few other speakers. So if this sounds gibberish to you, it actually happened. I gave this talk the first time at iOS Dev in Aberystwyth, and there is a coffee place that is called Coffee Number 1. And for us, it's easy to detect which parts of the sentence are food, Welsh cakes, for example. And we also know that the berry in Aberystwyth is not food. we also know that groceries in this context is an activity, and we also know that coffee is the name of a place, right? But for a computer, that's not easy to say. So how can we teach a computer how to understand the sentence? This is where vector embeddings come in. A vector embedding is a numerical representation of a word, a sentence, or any other unit of text. So here is a vector embedding for food. And I've cut this short because there are literally hundreds of numbers in there. And this array here is a vector, and we'll talk about why I say vector in a moment. But it has typically 768 of those floating point numbers in there. And those floating point numbers indicate the relative qualities of that term. And if we now look at the vector embedding for foot, you will notice that the numbers are different because it's a completely different concept. Some of the numbers are kind of similar-ish, right? So for example, the first number there, that is not too distant or not too different. And that is an interesting quality of those vectors. Who here knows what this is? All right, you in the front? GPS coordinates, right? That's correct. Anybody here can tell me where this is? Raise your hand. Somewhere in England. Yeah, it's London. So we know what vectors are because we've used them in school, and we also use them when we go on a hike, right? So here are more coordinates: Paris, London, New York, and Boston. And even from looking at those numbers, we can see that some of those places are closer to each other than other places, right? So we can see that Paris and London are relatively close to each other because we see the 48 and the 51 there in the first coordinate. And then we also notice that they, for example, London is further away from New York, for example, because that number is just much different. And if we plot this on a map, we can even see it more pronounced, right? So we can see that London is very far away from New York or Boston, but Boston is very close to New York in relative terms. Now for some maths. So, if you want to tell the difference between two places, you can take those vectors. And if you remember your maths at high school, you will remember that you've got your coordinate system, and you've got like the 0 point where those two axes meet in the middle. And then you can use the coordinates to indicate a spot on this coordinate system, right? So in the very left one, we see that the y arrow points to a place there, and then the x arrow points to another place. And now we can take the angle between those two vectors and run a cosine on it. So in the very left coordinate system, the angle between those two arrows is pretty close to 0. And if we run a cosine on it, that result will be close to 1. And that means those vectors are relatively similar. If we do the same on the middle, we see that they are very different, right? So they point in two completely different directions. So the angle is close to 90, and that means the cosine will be close to 0. And that means they are orthogonal. And on the very right, they are pointing in completely opposite directions. That means the angle is close to 180, and the cosine will be close to -1. And then we can say, okay, so they are very different, pointing into completely different directions. So we can use this technique to tell how similar two vectors are. So now we've learned how to do this for two-dimensional vectors. Now let's do the math for multi-dimensional vectors. Are you scared yet? Well, no. We're not going to do that because we're going to use a computer to do that. Humans are bad at doing that, but computers are really great. So I'm now going to show you how to do that in this application that I built. So introducing Cloud Functions for Firebase, which is a serverless product that allows you to write code that runs in the backend. So we say serverless, but of course there are servers. Google runs them for us, so we don't have to manage them. There is automatic scaling, which means that depending on the number of users that are using your application, Google will automatically scale this up to the demand that your application is facing. It will also scale down to 0, and you can specify how many instances you want to run maximum and also minimum. So for example, if you want to make sure that your Cloud Function starts up really quickly, you can set a min instance of 1. That means one of your there is always going to be a server or an instance that is able to run your function pretty much instantly. It's a trusted environment, and that means that it is super difficult to hack into that environment, right? So you'd either have to break the physical security and break into a data center, or it would be super complicated to go through several levels of firewalls to break into that. So that is why we call it a trusted environment, as opposed to your phone, which is not a trusted environment because people can do whatever they want on their phones. And we support different languages here. So we support JavaScript, TypeScript, and Python, which will be important in a moment. So how can you use Cloud Functions for Firebase? We support a number of triggers. So you can use them, for example, when a new user has signed up to your application, or when there is a Crashlytic alert, or when a file is deleted in cloud storage, or when somebody writes a new document into Cloud Firestore. And that is what we'll be doing. So I mentioned that we support 3 languages, JavaScript, TypeScript, and Python. So we're at an iOS conference. If you would like to see Swift support in Cloud Functions, here is your opportunity. I'm going to give you 10 seconds to grab a snapshot of that QR code and then drive that vote up. So this is what, and also, this is interesting if you have any other feature requests for Firebase, because our PMs look at this user voice dashboard on a regular basis. If you find anything that's interesting for you, give it an upvote. And if you have a feature request yourself that is not covered yet, feel free to add it. All right. So this is a Cloud Function, and it's written in TypeScript. And you can see here, it will run when a new Firestore document is written. That's why we use the onDocumentWritten function here. The first thing that we do is we get the data after the write has happened, or how the data will look like once the write goes through, right? So I want to know what's going to be in the document. So this trigger will always be will be run when the user adds a new article to the knowledge base. So I want to read that information. I want to read the URL, and I want to read the full text, and then I want to do something with it. So I'm taking the full text, and now I'm computing the embeddings for the full text of the article. So let's assume I'm adding an article that Antoine wrote. I'm taking the full text. I send that full text to an embedding model, and that embedding model gives me back this giant vector of numbers, and then the final step is to write this back into the database. So everything that we add will have a vector, and that vector will allow us to do a full text semantic search on our database. Now let's talk about retrieval augmented generation. So retrieval augmented generation is a concept that you use to tell an LLM to generate content based on a context that you provide. That context can be a PDF file that you upload, it can be a CSV file, or it can be a database. So a database might contain lots of different documents and a lot of data, so we can't possibly send the entire database to our LLM, so we need to be selective. How do we do that? Well, the user typically asks a question, so we can take that question and then retrieve the relevant data for it. So let's say the user asks, how does Swift concurrency work in Swift 6? So now I take that question, I turn it into an embedding. So I send it to an embedding model, I get back a vector, then I take that vector to find the nearest neighbors using this cosine similarity search that I showed you in the database. So the database will give me a number of documents back, and I can specify how many, so probably 3 or 5 would be a good number. And then I can take those documents, inject them into my prompt, and the prompt will be based on the following context, and then all those documents. Please answer the user's question, and then how does Swift concurrency work in Swift 6? And then finally generate the answer using the LLM. And here's how it works. So we have another Cloud function, and this Cloud function is an onFlow, which is a thing that is part of Genkit, which is our generative AI integration toolkit. It's similar to LangChain. And it is a callable Cloud function, so I can call it from my client. Here I specify what kind of data I want to inject into that flow, and then I go off and use what's called a retriever. So a retriever essentially is a smart way to query your database. What it does is it takes your query, what you see here on the 4th line in this box, it takes that query, computes the embedding for it, and then goes to the database and fetches the relevant data. So it's really just a smart way to query your database. And we can limit the number of documents we retrieve. So here I tell it to retrieve only 3 documents. Then I get all of that back. I map this into the context, and then I inject this context into my history so that I can have like a proper conversation using a chat interface. And here is my prompt. And this prompt is, you can notice the structure. It is what I created using this gem tool that I showed you in the earlier demo. And right there in the middle, you can see that I'm injecting the user's question. And here is more instructions on how to behave, analyze the context provided by me, reference my personal knowledge base, do not generate responses based on assumptions or speculation. That is really important. If I ask you about what you know, tell me only what you know, what's in my knowledge base, right? And if I ask details about you as a person, just provide basic info and then try to get the conversation back on track, right? So because otherwise, people might start making proposals and stuff like that. Right, more instructions. And then here we inject the context and the history. So that's a whole lot of stuff that we send to the model to generate. And then here I call the model. I'm using Gemini 1.5 Flash, and I could use any other model, right? So Genkit has a really cool feature where we abstract over all the different LLMs. So if you are unhappy with how Gemini works, it is super easy to use a different model. So if you wanted to use one of OpenAI's models, you could just swap out this constant here, and you'd be done, right? That's the only change you'd have to do in order to use a different LLM. Or you might be using different LLMs for different parts of your application, because you realize, oh, well, for some of my use cases, I want to have a very powerful LLM, but that might take a longer time to answer. But for some of my use cases, I want to use an LLM that can answer a lot quicker, even though the answer might not be as comprehensive. And then finally, we return the answer to the caller. Now, how do you call that? So you saw the TypeScript code on the slide before. This is Swift code here. So this is a part of my client application. And here you can see how you can call a Firebase callable function from Swift. So first of all, you set up the callable. You provide the type parameter, the parameters that you want to inject or send and that you want to return. And then you just call it like a regular Swift function, passing in the query, and you get the answer back, and you can display it to the user. All right, so we're looking good on time. Let's do a live demo. So all right, so here's the application. And I've added a couple of articles here. So this is an article by Matt Massicott. Non-sendable types are cool too, and you can see that the formatting is really, really clean. Let's look at another one. So this is how it looks like. We can get a summary. There's the summary. OK, so now let's go and chat. How does Swift concurrency work in Swift 6? Swift 6 introduces concurrency features centered around the type systems and actors. Isolation is a key concept where actors enforce isolation boundaries to protect mutable state. OK, so tell me more about isolation. Let's see. OK. Global actor isolation, non-isolated functions, and so on and so forth. So I think this is really, really nice. And it uses the history to so that I can have a real conversation with it. Cool. So that is how you use RAG in your applications to base your LLM in the data that is specific to your application. OK, so we did the demo, but all this typing, that is really cumbersome. How about, and I promised this in the beginning, how about we make Siri smarter and hook this up to Siri? So here's how you do it. You build an app intent. And in this intent, you specify the parameters that you need in order to run this intent. So I want to be able to just tap on my action button, or do a long press on the power button, or just say, OK, to invoke it. And either I provide the question right away, or if I don't provide the question, Siri needs to be able to tell the user, hey, you didn't provide the question. Please do provide this input, because otherwise I can't run this workflow. And then here is the perform function, and that is where the magic really happens. And you can see that we make a call to a semantic QA service. So this is really just a thing that calls the backend, the one that I showed you before. And then we return the result. And this is really nice. So this is one of my absolute favorite libraries out there. If you want to do any markdown, use this library. It's fantastic. So I'm using this to present the result as a nicely formatted markdown in the Siri UI. Okay, so let's do a demo. Let's go back to Bezel. Okay. Oh, and then let me first show you one thing. What can I do here?
Here's something you can try in Sophia.
Can you hear that, actually? Okay, so let's do it again. What can I do here?
I don't have any suggestions for Sophia.
Oh. What can I do here?
I don't have any suggestions for Sophia.
All right, but I think you might have seen it the first time around. It tells you what you can do. So and that's something that you can do in literally every application. So if you don't know how you can use certain feature or how you can use Siri in any of the applications that you have on your phone, open that application and then just say, what can I do here? And then it will give you all the Siri intents that you can use in that application. So let's give it a try. Search my knowledge base in Sophia.
Sure, what would you like to know?
How does Swift concurrency work?
Swift concurrency is a powerful feature that lets you write asynchronous code in a more structured and readable way. It's built around the concepts of actors and isolation, which help to manage concurrent access to shared data and ensure thread safety.
Don't you just love the Australian accent? So that is actually coming from our database. So now let's look into the database. And here is my project. So let's first look into the Firestore database. And you can see that I've got this collection here with all the artifacts. So just a few artifacts there right now. And here is the full text of an article, for example. And here is the vector embeddings field. We don't display the value because it doesn't really make sense. And it also doesn't make sense to edit the vector. So that's why it's not shown here. We have an AI monitoring dashboard. So that is something that shows me all my Genkit flows that I ran. And so, for example, here's the semantic QA flow. So I can go in there, and if we're lucky, we will actually see the one that I just ran. So you can see that this flow does a couple of things. So first, it uses the Firestore artifacts retriever to retrieve stuff from Firestore, but that needs to use the embedding model to compute the embedding. And then here you see, and let me make this larger for you to read. And here you can see the entire prompt, and you can see it starts with, your name is Sophia, and you are a knowledge assistant, and all this other stuff. And then here is the context, right? And you can see that I injected the entire full text of the article that we retrieved. And if we scroll down, we should probably see a couple of other articles it injected. You can see the scroll bar is pretty long. And then at the very bottom, we will see the user's question. For this thing, we didn't have any history. And then we can see the output. And there is a short summary, there is an answer, and so on and so forth. You can also see that apparently it tells the model to return the result as a formatted JSON object, and that makes it easier to use it in your application.